Hi, we are Bekan
and Sven, and today we would like to show you the advantages of our optical head for VNA to validate numerical simulation of mobile device antennas.
Okay Sven, let's start. What do we see here?
We see a numerical model of your prototype antenna that we also manufactured. That a numerical model was created in our simulation software, SimForLife. Here we see the near field distribution as well as its radiation pattern. And what we would like to look at today is the S parameter of the system. So we see here the return loss, the magnitude of the S11 parameter. And what I would like to use to validate antennas, because it simply contains a lot more information, is the complex valued S parameters that we see here in the Smith chart. And we are going to export this now to touchstone file that we can import later on the vector network analyzers to use this in a reference in our antenna performance measurements.
Okay, sounds good.
Okay, so let's go and have a look in the lab. Okay, Bayan, you imported the red curve, that is our reference from our simulation model. And if I look now at the white curve, it doesn't really look like what we have simulated. Do you have an explanation for that?
I think that the reason for this is all the cable currents. Just look what happens when I touch the cable. The results in the Smith chart change very much.
Okay, so in that moment I would just add some ferrites and see if this improves the situation.
Okay. Now we have the ferrites on and the effects of the cable currents is less visible. Look, when I touch the cable, not so much changes in the Smith chart. But the problem is that the overall result still looks very different from the target.
So that's probably because the cable becomes an element of the electrically small antenna, because by adding a boundary condition and changes the result compared to the measurement, which is fully isolated.
Shall we use the optical head for VNA and measure it?
Sure.
Okay, we're in front of the optical head for VNA, and I will connect now the antenna. What you see on the screen is two curves. So the red one is the result from the simulation, so the exported touchstone file. The white one is the actual measurement from optical head for VNA. There is a small difference in the Smith chart, but that is due to the phase shift caused by the adapter which we didn't simulate. As you see, the cable currents are the effect of the cable currents is much less. Of course, if I get very close to the antenna, I will detune it itself. But in general, the results look much better and they match the simulation very nicely. Can you explain what's the reason for that, Sven?
The reason for that is that we replaced this electrical cable that we used before with a fiber optical technology of the optical head for VNA. And I'm going to explain you this technology in a moment. The functional principle of the optical head for VNA is based on fiber optics. We provide a forward reference signal from the vector network analyzer that gets modulated onto an optical carrier inside the remote unit. Then transmit the signal to the antenna feed point. Whatever is reflected from that RF signal is sent through a coupler and then again modulated inside the optical head onto an optical carrier and via fiber optics transmitted back to the remote unit, where it gets analyzed on the second port of the vector network analyzer. Together with an open, short and load calibration and the PC-based software, we are then able to compute the S11 parameter of that antenna. Thanks for watching us today. If you're interested in the optical head for VNA or want to get more information about it, just contact us under info@speag.swiss or contact your local sales representative. You may also get in touch with us by leaving comments below this video.
Thank you and goodbye.